Hearty welcome to the video on questions for revision. Today at this video we will see questions from definite integral. Reference material in all chapters of class 12 is available easily to all the students, but the students are not able to gather necessary help because they need detailed explanation of the solution steps. They want recollection of the concepts required for the solution at required places, tips to do the problems with slight changes, and tips to reduce errors. The above needs of the students is taken care of at this tutorial series. Dear students, revision means looking back over previously learned information, ensuring that it is clear and fresh in the mind. To ensure that 10 questions per selected topic is compiled at this video, the answers to the compiled questions is presented in PDF and video format. Before you start viewing the video, download the question and keep it ready. This material is only a supplementary to the revision strategies planned and executed by your experienced teacher. Let's move on to question number 1. Evaluate integral minus pi by 4 to pi by 4 secant square x dx. Normally when you see this question, you will be tempted to write the answer as 0, thinking that minus a to a f of x dx is always 0. But remember, that is 0 only when f of x is odd function. But here secant square x is a even function. Well, let us do it directly, but you can use a property also. Tan x from minus pi by 4 to pi by 4. Now I have applied upper limit minus lower limit. Tan of minus x is minus tan x. I am applying it. It will be 1 plus 1. The answer is 2. Let us move on to question number 2. Evaluate integral 0 to pi by 2 e power x into sin x plus cos x dx. Here you should not do the problem directly. We have to use a property e power x into f of x plus f dash of x. There is a formula for it. Let us see. Now we know that if f of x is sin x and f dash of x is cos x in this problem, then e power x into f of x plus f dash of x is e power x into f of x. This is done through integration by parts, and there is a formula for it. In this problem, therefore, when I use that property, the answer is only e power x into sin x. From 0 to pi by 2, or e power pi by 2 into sin pi by 2, e power 0 sin 0. Therefore, the answer is e power pi by 2 into 1 into 0. Minus 0, therefore answer is e power pi by 2. Move on to question number 3. Integral minus 1 to 1 mod x minus 2 by x minus 2. Now let us try to find what is the nature of mod x minus 2. Mod x minus 2 will be x minus 2 for x minus 2 greater than 0 and minus of x minus 2 for x minus 2 less than 0. This is by property of mod x. Mod x will be x for x greater than 0 minus x for x less than 0. Therefore, to write it in this manner, x minus 2 for x greater than or equal to 2 minus of x minus 2 for x less than 2. Therefore, I am finding for the interval minus 1 to 1, mod x minus 2 is minus of x minus 2. Let us use it and try to get the value of this function. This function is minus of x minus 2 by x minus 2, simply minus 1. Therefore, it is minus of x from minus 1 to 1. The answer is minus 2. Therefore, the correct option is D. We'll move on to question number 4. Integral 0 to 2 square root of 4 minus x square equals. Direct question. We have to use the formula for root a square minus x square. We are having a formula x by 2 root a square minus x square plus a square by 2 into sin inverse x by a. Apply that formula. A is equal to 2 over here. I am applying it. Sin inverse of 1 I am applying. Sin inverse of 0 I am applying. The answer 2 into pi by 2. The answer is pi. Direct question. Let us move on to question number 5. Evaluate integral 0 to pi e power cos x by e power cos x plus e power minus cos x. Whenever you see a problem like this, when the lower limit is 0 and inside the integral you are having something which cannot be done directly, now try to use the property. Which property? Integral 0 to a f of x dx is integral 0 to a f of a minus x dx. Replace x by a minus x. In this problem, replace x by pi minus x. Let me replace. But now I have to know that what is cos pi minus x. It is minus cos x because it is in the second quadrant. I am applying it. Now I am getting e power minus cos x by e power minus cos x plus e power cos x. Now here one thing you have to remember, whenever I apply this property, integral 0 to a f of x dx property, the denominator you should get back the same, then only you can add. If it is changing, then you have to be very, very careful. But now I know that each integral is equal to half into sum of the two integral, and some book will write it as 2i. Why I am writing that half into? You may forget that 2 at the end to divide. That's why I am using this step for half into sum of the integrand. When I add the integrands, they are getting cancelled. Numerator, denominator getting cancelled. I am getting only dx. Therefore, half into pi. Therefore, the answer is pi by 2. If you use that 2i, you will get pi. Therefore, the answer is pi by 2. Well, move on to, this is the curve for that integral e power cos x by e power cos x plus e power minus cos x. Approximately you are getting the answer. Well, let us move on to the next question. Minus pi by 2 to pi by 2 cos x into log of 1 plus x by 1 minus x dx. Okay. Here once again use your common sense. If it is minus a to a inside the integrand, if you are getting a very, very complicated functions, you have to use the property that odd function, even function property. For that, we have to prove that this function inside is odd or even. I am taking it. I am finding f of minus x. Cos of minus x is cos x. Then log of 1 minus x by 1 plus x. You know that what is that log of 1 minus x by 1 plus x? It is, you can write it as minus log of 1 plus x by 1 minus x. Therefore, you are getting f of x is equal to minus f of x. What is the meaning of it? F of x is a odd function. Therefore, for odd function, minus a to a, f of x dx is 0. Therefore, the answer is 0. No need to do any integration. But in the exam, you have to prove that the function inside the integral is an odd function. Otherwise, marks will not be given. We'll go to question number 7. Integral 0 to pi by 2 cos theta by 1 plus sin theta by 2 plus sin theta. Now this looks like a problem where by substitution we can convert it into a problem of integration by partial fraction. Let us put the substitution. It will become integral dx upon 1 plus x into 2 plus x. Simple. Now directly you can do this problem by expanding the bracket, but I am doing it by integration by parts. Both are one at the same. I am getting the values of a and b by equating or putting x is equal to 1 or something like that. And remember, after getting the value of a and b, your job is only to integrate. That's all. Some problem is simple. Therefore, by putting x is equal to minus 2 and putting x is equal to minus 1, I am getting the values of a and b. Now this is the partial fraction. I am doing the integration now. Log of x plus 1 minus log of x plus 2. I am applying the upper limit minus lower limit. I am getting the answer as 2 log 2 minus log 3 because log 1 is 0. Go to question number 8. Evaluate 0 to pi x sin x by 1 plus cos square x dx. Once again, inside the integral you are having a highly complicated function which cannot be done by substitution and all. Therefore, apply the property. Property is replace x by pi minus x. That is sin pi minus x is sin x and cos pi minus x is minus cos x. The denominator is not changing, check out. After replacing x by pi minus x also, denominator is the same. What you have to do now? Half into add the integrand. X by sin x by 1 plus cos square x should be added with that. Take LCM. In the numerator, you will x sin x will get cancelled. You are getting like this. Now, this problem is a direct problem now, which can be done by substitution. What is substitution? Differentiation of cos x is in the numerator. Therefore, I take u is equal to cos x, du as minus sin x, and I am replacing them. Now, in this problem, you can convert the limit also by based on the substitution. When I change the limits, when x is equal to 0, u is 1. When x is pi, u is minus 1. Therefore, the integral will be from 1 to minus 1 minus du minus pi by 2 tan inverse of u from 1 to minus u, tan inverse of minus 1 minus tan inverse 1. It is minus pi by 4 minus pi by 4. Answer is pi square by 4. Let us move on to assertion and reason question. Here the highly interesting thing is the reason what is given there that gives you a clue to do the assertion. This problem can be given directly in the exam also. Check out. For this I am using the property integral a to b f of x dx is integral a to b f of a plus b minus x dx. How I got this idea? 2 plus 1 is 3. I am having 3 minus x in the denominator. Where I am using that? Wherever x is there, replace it by 3 minus x. Now you got this integral like this. Now each integral half into sum of the two integrand. I am adding them. When I add them, numerator and denominator is getting cancelled. You will get only dx. Therefore, when I substitute the upper limit minus lower limit, the answer is 1. Even though this is an assertion question, check out friends, this problem can be asked for 2 marks directly. You have to use integral a to b f of x dx as integral a to b f of a plus b minus x. Some of you may be tempted to do this problem by rationalizing. That also you check out. Sometime you may get, sometime you may not get. Let us go to the reason. Therefore, assertion is true. This is the reason. Reason is very simple. In this problem, the very clear problem is for doing the assertion, reason has given you the clue. Anyway, this reason is perfect, but the reason is used for to assertion proving. Therefore, both A and R are true, and R is the correct explanation of A. Move on to next question number 10. This is the assertion 0 to pi by 2 square root of 1 plus cos x dx is 2. Let us try to evaluate it. Inside the square root you are having 1 plus cos x, replace it by 2 cos square x by 2. Careful. 1 plus cos 2x is 2 cos square x. 1 plus cos x is 2 cos square x by 2. 2 comes out. Integration of cos x by 2 is sin x by 2 by 1 by 2. You got 2 root 2 into sin pi by 4 minus sin 0. Sin pi by 4 is 1 by root 2. Therefore, the answer is 2. Your assertion is true. To go to the reason. Reason is giving you a formula for dx upon root a square plus x square. Formula is perfect. Therefore, reason is true. But this reason is not used for the assertion. Therefore, both A and R are true, but R is not the correct explanation of A. Thank you friends. Success is dependent on efforts. All the best.